Hello, student. We continue our lecture in New Year about evolutionary algorithm. In previous section, we explained about the content of evolutionary computing of or evolutionary algorithm. As I said before, each evolutionary algorithm contain some parts, the representation that determine the representation of each individual or each solution. It is depend on the problem. For example, binary representation, each gene is 0 or 1. Real value representation, each gene is real value and or integer representation or another representation. Evaluation or fitness function is a function that get a solution and set a fitness or grade. The better grades show that individual or solution is better. Population is a collection of uh, solution in each loop or in each generation of algorithm. Parent selection. Each time we select parents, two parents, and combine or recombination them for producing new children. It is a parent selection. Sometimes it is random. And recombination is a method that combines the gene of parents, and mutation is the jumping the value in each gene value of offspring or children. Survivor selection is a selection method that selects from all both of parent and children for the next generation. Survivor selection sometimes is based of age, such as the nature, or is based of fitness based survivor selection. And determination, as we said, EA repeat and repeat and repeat until determination condition is occurred. There are some classic problem that cannot solve by some special mathematic method, such as 8 queen or knapsack problem. And we explained in previous session about the content of EA and some concept and the population, parent selection, parent combine, recombination, mutation, offspring or children, survivor selection, and this loop repeat and repeat until the reach to the end. It is a pseudocode that explained in previous section, and some idioms such chromosome. Chromosome is a solution or collection of gene, and evaluation or fitness function. Population at the first, it is most of the time produced by random. Parent selection mechanism that select parent for combine them, and some operation and mutation, recombination, survival selection, and termination and initialization. Uh, in this section, we want to explain about the continue of previous section. One of the problem that can be solved by EA is a 8 queen problem. This problem cannot be solved by some special mathematic way. In a chess sheet on in chess page, there are 84. There are 64 uh, location, 8 row and 8 column. If you put a queen in the location, this queen can move uh, this location. This dark location is a location that this queen can move. The 8 queen problem said that you must put 8 queen in a chess set that no one cross each other. For example, the second queen can put here, or the third can put here. But you can't put here, for example, because it cross or touch previous queen. The 8 queen is a classic problem for EA that can find the best location for the 8 queen in the chess set that no one touch each other. For example, at the beginning you must set a representation. You can set a binary representation. It is a 8 by 8 array of 0 and 1. 1 for queen and 0 for empty location. It is a binary representation that each solution or each chromosome or each individual contain an array with 64 location. Each location include 1 or 0. You have 64 location, and each location contain 2, 0 or 1. So you have 2 power by 64 combination, and it is a very large combination of solution. In other words, your search space is very large, and you must spend a lot of time to reach the best solution in this large space of solution. It is a binary solution, and it is a not suitable representation. So we change it into another representation that it is named as a permutation representation. If you attention to this array, each array have index. For example, index of index of row and index of column. 1, 2, 3, 4, 5. This. If you use the index of columns such as the index of previous representation, but the content of each location is the row of, for example, it is here, it is a row of first, it is a row of row index of this, it is a row index of this, and etc. It is a row of 8 and it is 8, it is 4, so it is another representation. In this representation, the representation includes a one-dimensional array with values from 1 to 8 that no one repeats. It is include all of combination of 1 to 8. It is a permutation combination representation. So we have 4 type of representation: binary representation, each gene is 0 or 1; integer representation, each gene have an integer value; real, that each gene is a real value; and permutation representation. Permutation representation is the same as integer representation, but one of the different is that no one the values are repeat. You have all combination from 1 to 8, but in integer you don't have this limitation. The search space of this representation is very lower than binary representation of this problem, because at the beginning of location you have 8 combination. For the second queen you have 5 row, because this row cannot be used. For the third you have 6th row, and all of this can be multiplication, and it is 8 factorial. 8 factorial is very lower than 2 powered by 64. So if you use this permutation, this representation, you can reach the best solution very faster than this. So the representation is very important for solving the problem. And the second part of the EA is a fitness. Fitness for this problem is a function that evaluates that how many queen touch each other. The lower number of touch, the higher value of fitness. So it is a penalty of, for example, if you have a 7 touch of queens, it is better than, for example, 3 touch. So we use the negative value because 3 is higher than 7. Negative 3 is higher than negative 2. The best solution is 0, the 0 touch value. Nobody of queens touch each other. It is the best fitness or highest fitness or maximum value of fitness. So we can use inverse or negative. Inverse or negative. Negative is better. One of the part of EA is recombination and one of is mutation. Mutation is a small change in each solution. As we say, the permutation is a formation of showing the values from 1 to 8. So a small change, for example, is swapping two values, for example 7 and 5. It is a mutation, swapping mutation for permutation representation. Recombination or crossover is combine two individual or two solution. We use one breakpoint and substitute the upper and lower or parent 1 and parent 2. It is a new children and it is a new children. One of the problem for this representation is repeating the value. Here you don't have this problem because all of 8 value here. But sometimes you have a repeating value, you must change it because the permutation representation don't include the repeating value. Selection, we have two selection as the parent selection. Most of the algorithms use random parent selection, but here use this method, pick 5 parents randomly, then select 2 best of them. Parent selection is not important for the problems, and most of the time we use random parent selection. Survivor selection. Survivor selection is a selection for the next generation. So from the parent and the children or offspring, we select some individual or solution for the next generation. For example, based of highest fitness, the best fitness select for the next generation, or based of age. For example, we can select only children for the next generation, or by some method it is a survival selection or replace the generation by the new generation for the next loop. It is a summary of solution of 8 queen problem. It is not only one possible solution. There are many solutions for this problem. As we say, the representation is permutation. Crossover is cut on brick, cut and crossfield. Recombination probability is 100% or it is occurred every time. Mutation is swap and it is almost of the time, it is 80% time. Parent selection best 2 of random 5. Survivor selection is replace worst. In this method, each time you calculate the fitness of all of the population, but the worst fitness is removed and new children used or replace it. Population size is 100 and number of offspring for crossover is 2. Initialization or population initialization is random, and termination value is execution of 10,000 fitness function evaluation. You can use another termination condition, for example, when the loop or generation reach to 1000 or reach to 500, or when the fitness don't change considerably, and another solution. Um, if it is a fitness function, at the beginning the population have some individual or solution with this location. When in the middle of the algorithm or middle loop, they tend to be better, and at the end of algorithm, all of the population have a high fitness value, but the best one is here. It is the best solution with highest fitness value, and it is our answer. Our answer is the best individual, or the individual of last population with highest fitness. Each curve of fitness value have this behavior. At the beginning it increases rapidly, but when it reached a high value, it increases slightly. Never it decline, because in the EA we save the best solution each time, and the best fitness or the best solution don't tend to be worse. As I say, the curve of fitness have two steps. The first step, it is increase rapidly, and the second step, it increase slightly. It is the behavior of all of the evolutionary algorithm. Some scientists proposed, instead of random population for the initialization, we can have a smart initialization. So instead of produce random population, we can produce a smart or a good population. It increases the speed of the algorithm to find the best solution or to reach acceptable solution. If we don't use a smart initialization, the algorithm may spend more time, but it reach the good or excellent solution. Evolutionary algorithms have many types and versions for many problems, and we explained the version and the specification of this algorithm in the next section. This algorithm is a robust tool. Robust means that evolutionary algorithm can produce acceptable or good solution for all problems that don't solved by a special mathematic way. Robust means it is acceptable answer. Sometimes it produces excellent solution, but sometimes it can't produce excellent solution, and it produce only a good solution. As you say here, the random search of solution produce low quality or performance. But when you can see, you can solve the problem by special way of mathematics, you can solve it rapidly with high quality of solution. But evolutionary can uh, solve the problem by more time and acceptable solution. EA have many decades and many historic and the best advance of EA occurred in 90 decade, or around 20 years ago. We have many types or many version of EA. The first version provide not good solution. The second provide good solution, and the third and fourth produce very high quality or excellent solution with a small or with lower time. EC is a optimization value that search the search space to find the best solution for algorithm. If an algorithm have a special solution in mathematics, we don't need to EA. But if a problem cannot be solved by special way of mathematics, we use EC. But we can't use EC for all problems. We can use EC only for problem that can be solved divide and conquer, by divide and conquer, or can be solved step by step. So EC is a way to solve problems that cannot be solved by a special mathematic method, and for only problems that can be solved step by step. It is named evolutionary, or divide and conquer, or we divide the problem into some part, and each time we solve each part. EC can compare with hill climbing. Hill climbing, for example, when you want to climb and reach the top of the climb, or top of the hill or mountain, the next feet of you put in the higher location, not in the lower head location. You increase the height and reach the best or top of the location. It is a content of this section that we learn about some problem that cannot be solved by a special mathematical approach, and such as Napestack, or such as 8-queen algorithm. And this algorithm can solve step by step, and each time you can find a solution with, for example, a lower number of crossing queens. Thank you very much.